Welcome back to Type 1 Diabetic Warriors. Hey, do you know where the ultimate answer for this disease lies? Well, I don't either, but I have a pretty good idea that it's going to have to do with cell engineering, whether they go in and through a single procedure re-engineer our own cells based on our own DNA, or option two, whether these cells that will save us come from a cell factory with specific characteristics that are lent to our specific needs. We have an update for you. It's fascinating stuff. You're really going to like this. Hit the like and subscribe button, and we'll get right into this on Type 1 Diabetic Warriors.
Thanks for joining us today. If you like our channel's content, feel free to hit the link in the description and buy us a coffee. We appreciate all our viewers who support our channel. Now on to our video. Your pancreas has a secret protector from your immune system. For millions of people living with type 1 diabetes, their own body is a battlefield. Day after day, their immune system, the very system designed to protect them, wages a relentless war on the pancreas. It meticulously seeks out and destroys the precious, life-sustaining beta cells, the tiny factories responsible for producing insulin. This internal conflict turns the body against itself, forcing a life of constant vigilance, blood sugar monitoring, and insulin injections just to stay alive. For decades, the central question has been, how do we stop this civil war? But what if, instead of trying to fight the war, you could simply make the targets invisible? What if you could give the pancreas a high-tech cloaking device to hide from its own misguided army? In a remarkable breakthrough, scientists have achieved just that. To get why this is so huge, we first need to appreciate the profound challenge of type 1 diabetes. Your immune system is supposed to be the most sophisticated defense network on the planet. It's a complex army of cells, including T cells, that patrol your body, checking the identification of every cell they encounter. Their mission: identify and eliminate foreign invaders like viruses and bacteria. In type 1 diabetes, this system makes a catastrophic error. It misidentifies the body's own insulin-producing beta cells, located in clusters called islets within the pancreas, as a threat. The T cells, acting like misguided soldiers, get the order to attack and systematically destroy them. As the beta cells vanish, so does the body's ability to produce insulin. Without insulin to regulate blood sugar, glucose builds up in the bloodstream, leading to devastating health consequences. For decades, islet cell transplantation has been a promising idea, but it always hit the same wall. The immune system would attack the new donor cells just as it did the originals, forcing patients onto a lifelong regimen of harsh immune-suppressing drugs. But that all changed with a landmark study published in the New England Journal of Medicine in August of 2025. Researchers at Uppsala University Hospital, in a trial using technology from Sana Biotechnology, revealed they had successfully transplanted islet cells into a person with type 1 diabetes without the need for those drugs. They achieved this by using the revolutionary gene editing tool CRISPR. Instead of creating new cells, they took existing donor islet cells and gave them a superpower: invisibility. Think of it this way: every cell in your body regularly shows its ID to passing T cells. This ID is a protein on its surface, a sort of molecular flag. A normal cell from your own body waves a friendly, familiar flag. An invading virus or a transplanted donor cell waves a foreign, unrecognized flag, which tells the T cell to attack. Previous transplant attempts required drugs that basically blindfolded the T cells so they couldn't see any flags, leaving the body at risk. This new approach is far more clever. The CRISPR edits don't blind the T cell. They make the transplanted cell's flag invisible. By deleting the genes responsible for presenting that foreign ID, the T cells just float right by, completely unaware that a new cell is even there. But the immune system has other tricks up its sleeve, like natural killer cells that look for cells that are hiding their flags. That's where the second edit comes in. By boosting the CD47 "don't eat me" signal, the engineered cells can calm down these other guards too. It's like having a top-tier security pass and a universal friend signal all at once. This multi-pronged cloaking strategy is what makes these cells so special, allowing them to function without being wiped out by the body's own defenses. This breakthrough doesn't just give us a new tool, it gives us a completely new therapeutic playbook. It shifts the paradigm from suppression, weakening the attackers, to evasion, making the target disappear. Imagine a future where a diagnosis of type 1 diabetes is met not with a lifetime of injections and finger pricks, but with a one-time procedure. A transplant of these lab-grown hypoimmune cells could restore the body's ability to make its own insulin, responding perfectly to meals and exercise, just like a healthy pancreas. This isn't just management, this is a true functional cure, restoring normal biological function without the need for constant outside intervention. This could revolutionize life for people with established type 1 diabetes. And by using stem cells as the source material for these cloaked islets, we could overcome the chronic shortage of organ donors, creating a virtually unlimited supply of life-changing cells. While some companies like Vertex Pharmaceuticals have seen incredible success with stem cell transplants that do require immunosuppression, this new gene editing approach could be the final piece of the puzzle to make these therapies safe and available for millions. The results are spectacular, but they need to be replicated in longer-term clinical trials. We are at the very beginning of this journey. Researchers need to confirm the long-term safety and durability of these edited cells. Phase 1 and 2 trials will focus on ensuring safety and effectiveness, followed by larger Phase 3 trials to confirm the benefits in a wide population. This process takes years, but it's the foundation of safe, effective medicine. While this specific CRISPR-based approach is new, it's part of a wave of innovation. Other companies like Vertex are pushing forward with different types of cell therapies, some of which are already in late-stage trials. The development of immune-cloaked, CRISPR-edited islet cells is a monumental leap in our quest to conquer autoimmune disease. For the first time, we have real-world proof in a human that we can transplant functional cells to cure a disease like type 1 diabetes without needing to close down the immune system. This is the kind of breakthrough that reminds us of the relentless power of scientific progress. The journey ahead is long, but for the first time in a long time, a true cure for type 1 diabetes feels like it's finally within reach.
Well, let me hear your comments about what you think about this cell engineering. I think there are going to be numerous clinical trials within the next couple of years. The best part is many hospitals, many different entities are working on this same thing. This idea of disguising your cells, wherever they come from, these re-engineered cells, disguising them from the immune attack without immunosuppression. That's what we want to hear. That's the ticket. And I think that will ultimately be the cure. So let me know what you think in the comment section. I always like to hear your thoughts. If they're all negative, don't bother. I'm not interested. Okay, you have a great day. We'll have another good video for you here real soon here on Type 1 Diabetic Warriors. Have a great day.